So if you've spent any time working in, modern software development, you've probably wrestled with this fundamental problem.
Oh, absolutely.
How do you deploy these complex applications, make sure they scale instantly, and then guarantee they just don't crash no matter where they're running?
Right.
And that's why we're diving deep into Kubernetes today, K8s. We're taking the sources you shared and just giving you the shortcut to understanding why this matters so much right now.
Well, it's essentially an open source platform, and it's all about automating the deployment, the scaling, and the management of containerized applications.
Okay.
But the real insight, the one that makes it click, is an analogy we keep seeing in the sources.
Which is?
Think of it as the operating system for your entire data center.
Ah, I like that.
It manages all the resources and processes for you, whether that's in the cloud or on-prem.
That analogy, the OS of the data center, that really sticks. Okay, so let's unpack this a bit. Where did Google get this ambitious idea?
Well, it wasn't exactly a fresh idea when they released it in 2014.
Right, it was based on their internal system.
Exactly. It was built directly on lessons they learned from their internal system, Borg, which was managing their, massive global applications for years.
So it was already battle tested.
Completely. And the brilliant move was taking that knowledge and giving it to the open source community, which is what drove its rapid evolution into the standard we see today.
And that transition was so critical because K8s solves this core problem of what they call container orchestration, right?
Right. That just means it's managing the full life cycle of those containers, not just launching them, but handling deployment, networking, scaling.
And availability.
And availability across a whole cluster of machines, which we call nodes.
And that consistency is so important, especially when we talk about the real world advantages that save operations teams these huge headaches. For you, the listener, the benefits are just game-changing. We're talking about automatic self-healing. So if a container crashes,
the case just restarts it.
It just restarts it. And it reschedules that workload onto a healthy node. And crucially, it manages rolling updates and rollbacks without any application downtime.
None. And that consistency across environments is a massive architectural shift. Your app runs the exact same way in development, testing, and production.
So how does it do that? How does it deliver on that promise?
To get that, you have to look at the key abstraction, which is the pod. Now, while containers hold your application code, a pod is actually the smallest deployable unit.
Okay, so it's a grouping of one or more containers.
Exactly. The core insight here is the K8s abstracts the container away from the machine using the pod.
So you're not just running a single container, you're guaranteeing that a set of related containers, like say your main app and maybe a logging sidecar, they always run together.
Always on the same machine, sharing resources. Think of a pod as a kind of shared utility belt. That guarantee of co-location is how these complex distributed apps can function so reliably.
And I imagine that brings some efficiency gains too.
Incredible efficiency. K8s is constantly packing those pods onto servers in the most efficient way possible. It improves resource utilization, which lowers costs.
And what about security?
On the security front, it uses config maps for non-sensitive data and then secrets for your sensitive credentials.
That brings up a great point. We keep hearing that K8s is the default for modern apps, but if it requires so much understanding, aren't you just trading one kind of complexity for another?
That's the fundamental tension. But the security gain is substantial. K8s gets rid of that old pain point of hard-coding passwords or using fragile config files.
Right.
With secrets, K8s manages those sensitive things centrally and only injects the credentials into the containers that need them and only when they need them.
So what does this all mean for the industry? I mean, K8s is now the foundation for modern microservices, right?
For sure. It lets teams break down those huge monolithic apps into smaller, manageable services. And it turbocharges CI/CD pipelines.
Making continuous deployment seamless.
Which leads us right to the cautionary note we saw. K8s is powerful, but it demands a real commitment.
The learning curve.
The steep learning curve is real. You have to master things like YAML configuration files, understand complex networking models, and then manage the control plane itself, the brain of K8s.
And that control plane has its own overhead.
It does. It has resource overhead. If you don't manage and optimize the cluster properly, you can actually cancel out those cost savings you were hoping for.
So K8s delivers phenomenal power and consistency, but that power is it's earned through real expertise in management.
Exactly. And if we connect this to the bigger picture, you might want to look at the future trends. The platform is constantly evolving.
Okay.
We're seeing more serverless architectures being built on top of K8s, and we anticipate big advancements in how it integrates with AI and machine learning.
Which raises a pretty big question.
A huge one. How will Kubernetes adapt to manage the vast high-performance infrastructure that's going to be required to power the next generation of intelligent, data-intensive applications?